So I just wanted to kind of share what I've sort of learned and how I've kind of found it useful. I found that Desmos worked really, really well to help them because it's not super cumbersome in terms of the calculations, and it can do a lot of stuff for them, and they can focus just on sort of the details, the key things that I want them to pull out. So in that 3C course, there's a lot on different models. So looking at linear versus quadratic versus exponential. And we spend a lot of time looking at the different equations, the key pieces. So one of the things that I found cool about Desmos is you can give them a set of data, or you can get them to collect a set of data, and then you can use it to model an actual equation that you think would fit the set of data. So the first one is a linear model. The way the modeling equations work is with your variable, you just put a 1 beside it, and that picks up the Y column of the data table. You can use the tilde, the little squiggly thing. This one here we think might be linear. So I type in my general form of my linear equation, and it spits out for you what your potential slope value would be, what your potential y-intercept value would be. And it also tells you information about how good of a fit it is. So when I do this with my kids, right, we talk about like how we know it's a good fit and what the key pieces we look for. So it's basically allowing us to take real data. And this data that I used here was taken from Stats Canada. I'm probably modified it a little bit. It just allows us to bring in sort of that real world data and allow us to apply those models to it. So I've done it for linear, quadratic, and exponential. And the equations are always the same. It's just the only thing you have to remember to do is put a 1 beside your y and your x variable and a tilde instead of an equal sign. So if I'm looking at quadratic, I could do a vertex form and it'll spit out my quadratic for me. I've done this assignment, especially for quadratics, with pictures. So I get them to find a picture of something that looks like a quadratic shape, and we do the modeling, and then we can talk about application questions. I've done it from a video where I've taken a video of students throwing a ball back and forth, and then I've taken stills at different time intervals and used that to help them collect the data. So there's a bunch of different ways that you could do this. As long as you have a data table set, you can use those models. This year I'm teaching a lot of calculus. So we do a lot of stuff on derivatives, particularly derivatives of trig functions and exponential functions are the ones that students find more challenging. So I've used activities where we're looking at how we find the derivative of sine and cos. So looking at how we can move these purple dots so that the tangent lines match the slope of the curve, and basically getting that relationship between the derivative of sine and cos and the derivative of cos and negative sine. So just kind of using it as an introduction. This year, with being completely virtual, I tend to throw them into their breakout rooms and get one student to share their screen with the activity on it. And then they can talk in their little pods of 3 or 4, and I can kind of watch and jump between breakout rooms. Steve's going to show you the teacher view, so how I kind of creep what they're doing and then jump between their breakout rooms based on who needs help or who's stuck at a particular spot. It doesn't have to be in an activity form. You can do it just in the regular Desmos calculator. So when we're talking about derivatives of exponential functions, I tend to just pop in random exponential functions. And you can, if you give it a label, you can tell Desmos to take the first derivative or even like the second derivative just by typing in f prime of x or f double prime of x, and it pulls up the graph of that derivative and second derivative. If you haven't noticed already, in addition to a graphing calculator, they also have a scientific calculator. So if you have students like my 3Cs struggle to type things into their calculator because it involves lots of brackets, getting them to use the Desmos scientific calculator is sort of a nice way for them to be able to see what's on the screen matches exactly what's on their piece of paper and avoids that like finickiness of brackets and brackets and brackets.